I'm Alex. This is Code Along with Alex, and let's configure default CPU requests and limits for a namespace. So I'm going to dive right into Killer Coda, which is the Kubernetes cluster we're using today. Super convenient playground that has kubectl configured for us from the get-go. And so to follow along today, you will need a Kubernetes cluster and kubectl configured. Otherwise, we should be good to go. So a Kubernetes cluster can be divided into namespaces, which is something we've talked about before. If we create a pod within a namespace that has a default CPU limit, and any container in that pod does not specify its own CPU limit, then the control plane assigns the default CPU limit to that container. Kubernetes assigns a default CPU request, but only under certain conditions that are explained later. Let's look. Okay, so to start, we'll create a namespace for our work so that we're isolating our tinkering in case you're using a real cluster, which you probably shouldn't be. So use a playground. Start with kubectl create namespace, and we'll call our namespace default CPU example. And you can see that our namespace was created. So we're going to declare some YAML next, and we're going to write a manifest for an example limit range, and the manifest will specify default CPU request and default CPU limit. So let me create a YAML called CPU defaults.yaml, and let's open it with Nano. And to start, we'll declare an API version 1 kind. Let's call it a limit range. Metadata. This will have a nested field called name, and we'll set the value to CPU limit range. Next, we'll declare a field called spec. It'll have a subfield called limits. That'll have a subfield called default with yet another subfield called CPU with the value of 1. Then we're going to have on the same level as default, a default request, and that'll have a child of CPU, which we'll set to 0.5. And then finally, on the same level as default and default request, we'll specify a type, and we'll set that value to container. Awesome, let's save this and get back to kubectl. Pardon the barking. Dogs will be dogs. It's Tallulah again. If you're here from previous videos, you'll know she's a barker, but we're getting Savannah as well. It's a symphony of Staffordshire Terriers. All right, so we'll get kubectl apply -f, and then we'll specify our file CPU defaults, and then we'll also specify a namespace, and we'll pass our namespace CPU or default CPU example. Awesome. So now if we create a pod in our default CPU namespace, and any container in that pod does not specify its own values for the CPU request and CPU limit, then our control plane will apply these default values: a CPU request of 0.5 and a default CPU limit of 1. Awesome. So next, let's declare another manifest, this time for a pod with one container, and we're not going to specify the CPU request or the limit. So let me create a file called CPU defaults pod.yaml, and then let's open that with Nano. Specify an API version, kind as pod, metadata. We'll have a name field called default CPU demo, a spec field. We'll have a subfield called containers. The first one, or the first subfield of containers, will be the name, default CPU demo, CTR for container, and then the image we're using is Nginx. That looks great. Now let's save this, get back to control plane, and actually create our pod. Do that, kubectl apply -f, and then our file CPU defaults pod.yaml, and like before, we're going to specify the namespace to be our default CPU namespace. No, it's not called that. Default CPU example. Great. Error. All right, let's go back to Nano and see where I might have beefed up. API version, okay, kind. Metadata. That looks fine. There's no space between the name and then maybe that doesn't like that. I wouldn't be surprised. Okay, let's try it again. And it was that. So you got to put spaces between your key value fields or key value pairs for your YAML fields. Okay, so now let's view the pod specification. Again, using kubectl. We're going to do kubectl get pod. Pass the name of the pod, which is called default CPU demo. And we want our output in YAML format. And we're going to specify our namespace, which today is default CPU example. And so you can see a bunch of YAML was output to our terminal. But let's navigate to the containers section under the spec field. And then you'll see that we have our Nginx image, the name that we specified, and then resources, where the CPU limit and the requests match what we specified previously. So that's nice. We didn't declare it in this pod manifest, but instead the namespace defaults were applied. So now that we've done that, let's kind of examine the different behavior for when you pass perhaps just the CPU limit or just the request, but not both. So we know we already know how it behaves when you pass neither. It just uses the defaults. But let's examine what happens when you just specify a CPU limit, but not a request. So to do that, I guess we can first delete our pod. We don't even need to delete these pods. It's fine. It's good housekeeping, I guess. It can't hurt. It's kubectl delete. And then what was the pod name? I already forgot. Default CPU demo namespace equals default CPU example. Okay. I have to specify the resource type to delete pod. And we deleted the pod. There we go. All right. Now let's move on. So we're going to specify a CPU limit, but not a request. Let's create a new YAML file called CPU defaults pod2.yaml. And then let's open it with Nano. Got to declare an API version. Kind. metadata name, which will set the default CPU demo 2 spec, and we'll have a containers field. First, we'll declare name default CPU demo 2 container. Then we'll have an image, which will be Nginx again. Then we'll declare resources. And to start, we'll just specify limits, which today will just be a CPU 1. Save that. Let's create the pod. kubectl apply -f CPU defaults pod 2 namespace equals, I always forget the name, default CPU example. It's thinking. Pod created, sick. Okay, and now let's view the specification in YAML format. kubectl get pod default CPU demo 2 output equals YAML namespace equals default CPU example. And if we navigate to the resources subsection, you can see limit CPU is 1, request CPU is 1. And so the request is set to match the CPU limit. And so the container was not assigned the default CPU request value of 0.5. Okay, so let's delete this pod and then try the last flavor where we specify CPU request but not a limit. So we'll do kubectl delete pod, and then our pod name is, these are pod default CPU demo 2, and then the namespace equals default CPU example. Pod is deleted. Okay, cool. So final flavor, CPU request specified but not a limit. Let me create one last YAML file. We'll do touch CPU defaults pod -3 YAML. Now let's open that. Oof. There we go. API version v1 kind pod metadata name default CPU demo 3 spec containers name is default CPU demo 3.ctr-ctr image is Nginx resources requests, and then we'll specify CPU 0.75. That look good? The correct nesting? It does. All right. And if it's not, we'll find out shortly. So let's now create the pod. kubectl, kube create, kubectl apply -f, and then it's going to be CPU default pod -3, and then namespace equals default CPU example, right? Yes. Okay. So our pod's created. Now let's check the specification of that pod. kubectl get pod default CPU demo 3 output in YAML. I did not specify the namespace, and there's no such pod in default namespace, hence the error. Default CPU example, boom, a bunch of YAML. We navigate to the resources section. You'll see that the CPU limit is 1, while the requests are 750 megabytes. So the output shows that the container's CPU request is set to the value you specified at the time you created the pod. In other words, it matches the manifest. However, the same container CPU limit is set to 1 CPU, which is the default CPU limit for that namespace. Okay. And then as we kind of close up, let's briefly delete that pod using kubectl, delete pod, and it's called, I already forgot what it's called, my goldfish memory, default CPU demo 3, namespace equals default spelling CPU example, and the pod's gone. Okay. So there's 2 restrictions that a CPU resource quota imposes on a namespace, and this is straight from the Kubernetes docs. For every pod that runs in the namespace, each of its containers must have a CPU limit. Secondly, CPU limits apply a resource reservation on the node where the pod in question is scheduled. The total amount of CPU that is reserved for use by all pods in the namespace must not exceed a specified limit. So this is when it's good to like delete pods that aren't being used. So when you add a limit range, if any pod in that namespace that includes a container does not specify its own CPU limit, the control plane applies the default CPU limit to that container, and the pod can be allowed to run in a namespace that is restricted by a CPU resource quota. Okay, so now let's clean up and then get centered for what's next. So we're going to delete our namespace. It's easy as that. So this was our whirlwind tour of namespace configuration, or I guess CPU, configuring default CPU requests and limits in a namespace. So it was kind of a continuation of what we did previously, but a different component of our system configuration. But I want to thank you for joining me today. It's a lot of fun. I hope you learned something and enjoyed yourself. My name is Alex. This has been Code Along with Alex, and I hope to see you next time. Bye.